Given 2 points, as we see here, what we want to do now is determine the length of the line segment connecting these 2 points. So let's look at this example here. This point has the coordinates 1, 4, and this point has the coordinates 5, 10. The strategy we employ is to see this line segment as the hypotenuse of a right triangle. So how do we form this right triangle? Well, we simply start at this point B and draw a line parallel to the y-axis. Likewise, we come over here and draw a line parallel to the x-axis, and where they meet, we place this vertex. Notice that this point is right below this point, so it has to have the same x-coordinate. Likewise, this point is right across from this point, so it has to have the same y-coordinate. So this point then has to be 5, 4. So now that we have a right triangle, we're going to apply Pythagoras' theorem, which says that the square of this side is equal to the sum of the squares of these two sides, which means then that we have to find the length of these sides. Well, if this is the point 1 and this is the point 5, it should be easy for you to determine that this length is 4. Likewise, if this is at 10 and the y value here is 4, then the length here is 6. So the x values run from 1 to 5, giving us 4, and the y values run from 4 to 10, giving us 6. Perhaps a more proper way to look at this is to say, well, the length of this line is 5 minus 1, and here the length of this line is 10 minus 4. So the length of this line is the difference in the x coordinates, and the length of this line is the difference in the y coordinates. So the length of AB then is simply going to be equal to the square root of what? 4 squared plus 6 squared. And that gives us 7.21. So the square root of 4 squared plus 6 squared is 7.21. So check this to make sure that it's correct. Let's look at this example. A is the point minus 4 minus 3. B is the point 6, 9. We complete our little right triangle. Notice the vertex is right below B, right across from A. So this point has to be 6 minus 3. Has the x value of B, the y value of the y coordinate of A. So how do we get the length here? Well, one way to look at this is to say that B is 9 units above the x-axis, and this point is 3 units below the x-axis, so 9 plus 3, 12. But more properly would be to say 9 minus a negative 3. So note, not 9 minus 3, it's 9 minus a negative 3, which gives us 12. Likewise, this length here is going to be 6 minus a negative 4. From an intuitive point of view, you can simply say that this point is 6 to the right of the y-axis, and this point here is 4 to the left, so giving us a total of 10 units. So in this case, the length of AB is the square root of 10 squared plus 12 squared. So you can do this on your calculator, and you'll see you get an answer that's approximately 15.62. So this should be fairly easy. Given 2 points, calculating the length of the line segment connecting those 2 points should be very, very easy. So let's look for a general formula. If I have some point A with coordinates xy and some point B with coordinates xy, we can use the subscript A so that we know that the coordinates x and y belong to the point A, and we use the subscript B here so that we know the points x and y belong to the point B. Of course, then if we complete our little right triangle, this point will have x coordinate equal to xb and y coordinate equal to ya. So to get the length of this line segment here, let's suppose we say the length is d. I can just write a d here. Well, d will be equal to the square root of the square of this length plus the square of this length. And so this length here will be what? Yb minus ya, and this length will be xb minus xa. So that should all make sense. You shouldn't have to memorize that by rote. Make sure that as you remember these things, that you do so simply because they make sense, not simply because you memorize it by rote. So this gives us our formula. So this should not look scary at all. It's just Pythagoras' theorem. The square root of what? The sum of the squares of these two sides, where this side is the difference in the x coordinates and this side is the difference in the y coordinates. Notice how I always say these equations using words. I don't just say square root of open parentheses xb minus xa squared. That's not how you should do this. You should talk about these equations in a way that makes sense. Finally, we have this example. Find the length of the line segment connecting the points minus 4, 7, and 11, 3. Now, we could do this quickly just using the formula. Even if I did that, I would not be using the formula like from some kind of basic memory. I'd be imagining the triangle in my head. So let's draw that then. Let's draw this little let's place these points roughly on our Cartesian coordinate plane. So minus 4, 7 is somewhere like that, let's say, and 11, 3 is somewhere over here, let's say, right? So it's 11 and up 3, that's minus 4 and up 7. So that would be something that looks kind of like that. And so then this then would give us our little triangle here. Not very neatly drawn, I apologize for that. And so this would be the point minus 4, 7, and this would be the point 11. And so we want the distance there, so let's just use capital D for the distance, and it'll be what? The difference in the x's, so that's going to be 11 minus a negative 4, and then we square that, and the difference in the y's, that's 3 minus 7, notice, squared. So this gives us 11 minus a negative 4 gives us 15 squared, and 3 minus a negative 7, that gives us minus 4 squared, which is 16. So let's write minus 4 in here like this and square it. So that gives us the square root of 225 plus 16, which gives us the square root of 241. And so D then is approximately 15.5 units. Okay, so that brings us to the end of this lesson. Bye for now.